Hello everybody, welcome back. Today in the next couple of videos we will be finishing off chapter 5. So today we're going to start with 5.7, interpreting graphs of linear functions. So our focus today is going to be using intercepts, rate of change, domain and range to describe the graph of a linear function. We'll get a lot more into it once we get into chapter 6. The two chapters really go hand in hand, and we'll look at other ways of looking at and how to graph a function. Okay? So we're going to jump right down into the example. The first example, example 1, says determining intercepts, domain, and range of the graph of a linear function. So this graph shows the fuel consumption of the scooter with a full tank of gas at the beginning of the journey. So this was similar to one of the questions we've done in a previous example in one of the other sections. So obviously, it may not be linear. I mean, if you go faster and slower, but overall the average looks like this, okay? So write the coordinates of the points where the graphs intersect at the axis. So right here, this is called the vertical intercept, or what we're going to learn to be the y-intercept. And this is going to be the horizontal intercept, which we're going to focus and look at what's called the x-intercept. So to answer the first question, A, here we are. So I just copied it directly from our notes, all right? So on the vertical axis, which is right here, you'll see a point at 0, 8. So that we write that as a coordinate, 0, 8. So the vertical intercept is 8. This point of intersection represents the amount of gas in the tank when the distance traveled is 0. So a full tank of gas on this scooter, so the tank would have 8 liters, okay? And again, it's at travel at 0 kilometers. We haven't gone anywhere yet. So basically, we can make an assumption that the capacity of this tank is 8 liters. All right. Next is the horizontal part, the horizontal, and what that represents. So the horizontal is going to be right here, the distance or the x-axis. You'll notice that there's a coordinate at 200, 0. So that's how we say the coordinate. In other words, always x and y are horizontal and vertical. Right, left, right, up, down. So we have 200, 0. The horizontal intercept is 200. This point represents the distance traveled until there's a volume of 0. So the tank is empty. That means that the scooter can travel 200 kilometers on 8 liters of fuel. Okay. Next, we're going to look at the domain and range, and we'll write these out. So remember, it's important to remember that you'll notice that in our graph here, if I take a look at the graph, we're only using quadrant 1, the positive, positive, all right? So that's because we're not going to have a negative distance, and we won't have a volume greater than 8 because this is the highest amount. And we won't have a volume of 0 because that means there'd be no fuel and you're into fumes, I guess, if you want to think of it that way with respect to the question. So it's only positive distance values and positive volume values for this particular example. Okay, so you have to take this in consideration when you're writing domain range. I'm going to show two ways to write the domain and range here today. The first, let's take a look. We'll look at the domain. All right, and so I'm just going to insert domain, and usually what we'll do is we can just write it as an interval. So remember I showed you 3 ways the other day. We could have the interval notation. So we could have square bracket 0, comma 200. All right, that's one way to show the domain. Remember, domain is your horizontal. Okay, I'll make this red for us. So there's some different ways to write the domain. That's the first one. All right. Or we can write it showing from least to greatest. So we say 0 is less than or equal to, we'll use D for distance, which is less than or equal to 100. So this means that it's in between that interval. Or we can use set notation. It's a little fancy. Remember, I call the squiggly brackets, right, the braces. All right, and we could say that we just literally copy this out. It's very similar to the last. And again, this will depend on your teacher or a professor, depending. All right, and we put comma. We say D is an element of the real numbers. All right. And I should have put, sorry, don't mind me, I should take this, draw this back a bit. D, and then we'll use that little line, remember the such that. Okay. Sorry, D such that, and then cut that out. Sorry, folks. There we go. Cut that. This should be good. Two sets of brackets there. My apologies. So D such that 0 is less than or equal to D, less than or equal to 200. D is an unlist. You don't need to use this notation for me. I'm okay with this or this. All right, but just be mindful of that is another way to write. Okay. Next, we'll do the range. So the range, remember these are the vertical values. So again, we'll go from least to greatest. So we'll use interval notation, 0, 8, so empty fuel tank represents 0. And remember, this is not a coordinate. And then 8 was the highest. So or, and we can show it the same as we showed here. We could say 0 less than, and we'll use capital V for volume, 8. So this shows that it's between here. And then we can use the fancy interval notation. Remember, I don't need all three. All right, these are ors. So we say volume such that 0 less than or equal to V less than or equal to 8. And volume is an element of the real numbers. And remember, we're using real numbers because it is continuous data. The graph is connected. So if it's like, if we have just dotted or certain intervals, sometimes we'll use whole number integers depending on the scenario. But that's what we need for this particular example. So 3 ways to write the domain and range. I recommend the one of the first two. This is the one that's more that we use a lot in grade 10. The textbook uses this one. Interval notation is another good way to show it. Square bracket shows that it is included. Round brackets not. So just be mindful of that. Okay. Next, what we're going to do is we're going, there's the rest of the check your understanding. Okay. You guys can do that. The next one is sketch, example 2 says sketch a graph of a linear function in the function notation. So we're going to sketch the graph here. So we will learn how to plug that in, but I'll show you how to do this step by step using a program that I really like called Desmos. I'm going to show you how to do that on a sketch, okay? And then take a picture of that as well as we work, okay? So in this example, since we have a linear function, which I'm not, based on the information we have so far, that might not be completely clear, but you may have learned that in previous grades. If not, we'll talk about that in class of how to represent that or how to see that. So what we do is we determine what's called the x and y intercept. All right, and how to find the y intercept is there's a y-intercept when x is equal to 0. So if it falls along the vertical line here, then the y-intercept, which like I said, falls along the vertical line, x is 0. So I say let x equal 0. So if we let x equal 0 in the formula, then we solve for y. Okay? Remember, this is just function notation. This is the same as saying y is equal to, right? And filling it in. But they just want us to get comfortable with that function notation. So we take our formula, and everywhere we see x, we put in 0. Okay? So, solve that. Negative 2 times 0 is obviously 0, leaving us with plus 7, leaving us with 0 plus 7. Again, so f of x is equal to 7. F of x, or f of 0, sorry, that is y. That is equal to y. So the y-intercept is 7. So we go up to a point here. I'll show this on the Desmos graph. So this point is going to be 0 and 7, right? The y value is 7, and then we have this coordinate right here. There it is, 0 and 7, okay? And then let's go back to our second one. We're going to determine the x-intercept. Because for a linear line, you only need 2, and it told us a linear function, so it's a straight line. I missed that before, my apologies. So to determine the y-intercept, we do this, or the x-intercept, we do the same thing, but this time we say that y equals 0. All right. Now, by saying that y equals 0, that's the same as saying f of x is equal to 0. All right? Because, as we discussed, they're equivalent. F of x and y are equivalent. That's just our function notation. So, let's get our formula. Everywhere we see f of x, we put in 0. So 0 equals, and then we solve for x. So we subtract 7 from both sides, which gives us negative 7. Oh, get my negative, like a bigger negative sign there. Negative 7 is equal to negative 2x, right? So we subtracted 7 from both sides. Next thing we want to do is divide both sides by negative 2, and that'll give us, so it gives x is equal to negative 7 divided by negative 2, which is equal to negative 7 over, I should be using my other, but that's fine. And remember, a negative divided by a negative is positive, so it just becomes 7 over 2. Okay, so x is equal to 7 halves. So to get 7 halves, that's the same as saying 3.5 if you wish. Remember, I prefer to just leave it as a fraction. But to show that, it'd be between 3 and 4 on your graph. So we'll go to our Desmos graphic calc, and we'll put, remember, 7 over 2, 0, label it, and there it is, 3.5. It's coming up. All right. So now we take a ruler and we just connect the lines. So we take a ruler, we connect the two, and remember the graph goes on either way forever. So we're going to connect the lines with a ruler, and there they go right through, and there's your graph. That's simple. Okay? So we put a ruler going through both points, take a straight edge, and we calculate it through, and there's your graph. And I'll cut that. Oh. Make it a little smaller. Context. There it is. And again, I'll show you that on the board as well. And you can do a check to understand the question. And that's how you graph the line. Okay? That's how you sketch a graph. You can do another few points, but 2 is enough. It doesn't hurt to have a few more. And again, to get any point on a line, you would just pick any value for x. We could say that x is equal to 1 and plug it in, right? So we could say let x equal 1. Again, this is just fine. And if we set it equal to 1, then we would just put f at 1 in, put the 1 in here, and that's going to equal 5. So the point would be 1 and 5. You go over in the graph, and you'll see that 1 and 5 is right here. So that's it for this video. We'll continue with example 3 in the next video. Thanks everybody for watching, and we'll talk again soon. Thank you.